Hi all. Let's see the next topic of multiprocessors, interprocessor communication and synchronization. So in this lecture we are going to discuss about an introduction to what is an interprocessor communication and how the interprocessor synchronization works. So coming to an introduction, as we know in a multiprocessor system there will be multiple processors which are connected, and there must be some facility for communication between the multiple processes that are present in the system. So a communication path has to be established by means of a portion of memory or a common input output channels, so that the sending process, it will send a request in the form of a message or a procedure and places it into the mailbox which is shared between the which is present in the shared region between the two communicating parties. And there are also status bits present in the common memory or the common shared region, which tells us the information about which process is sharing that particular region of memory. And at the receiver process also can check the mailbox periodically to see whether the sender process has sent a message. So that in the particular common shared region in the form of a mailbox, the communication takes place between the sending process and the receiving process. But here in this particular procedure, there is a disadvantage where the response time is time consuming. So the sender will place a message into the mailbox, no matter it doesn't know when the receiver will read the message and it can communicate again. It is a time consuming task. So in order to overcome this, a more efficient procedure is nothing is like the sender process will alert the receiver process whenever it is ready for sending a data, or whenever it is ready to communicate with the receiver. It sends a message or to the particular receiver in the form of an alert by means of a special signal called as an interrupt signal. So in addition to the shared memory, a multiprocessor system also have certain resources which are shared between the multiple processors which are present in a system. So in order to prevent the conflicting use of a shared resources by several processors, there should be some provision or some means of assigning the resources to the processors. And this task is done by means of an operating system. So there are three types of organizations which are used in the design of an operating system, especially for a multiprocessor operating system that implements the efficient interprocessor communication and synchronization between the processors. And the three organizations are the master slave configuration, separate operating system, and distributed operating system. They are the three different types of organizations which are used in the design of an operating system for a multiprocessors. So coming to a master slave mode, only one processor will act as a master among multiple processors, where all the remaining processors acts as a slaves. So here the master's job is to always execute the operating system functions, whereas the slave is responsible for executing all the remaining user defined functions. So in case of a separate operating system organization, each processor can execute the operating system routines whenever it wants. There is no specific processor which is assigned only for operating system function. Any processor, depending upon its requirement, whenever it needs, it can access the operating system routines, it can execute. And this is more suitable in terms of a loosely coupled system. The next type of an organization is a distributed operating system organization. And here the operating system routines are distributed among multiple processors. But only one processor at a time is assigned to execute the operating system function. All of them cannot execute at the same point of time. So each particular operating system function is assigned to only one processor at a time, and it can be executed by only one processor at a time. So we can call this distributed operating system also as a floating operating system. So coming to a loosely coupled systems, in case of a loosely coupled systems, there is no concept of a shared memory for communication between the processors. And here the communication takes place by means of message passing by means of an input-output channels. So here the communication is initiated by one processor, and that particular processor calls a procedure that resides in the memory of the other processor that it wants to communicate. And the efficiency of this communication depends upon the type of a routing protocol that we implement, the speed of the particular processor, the data link speed, and what is the topology in which the particular processors are connected in the network. Next, coming to a inter-process synchronization. So inter-process communication and inter-process synchronization are very important aspects in terms of a multiprocessor systems. As we know, the instruction set of a multiprocessor, it contains a basic instructions that are used to implement the communication and synchronization between the different types of processes, and especially between the cooperating processes. When we talk about processes, there are two different types of processes. As we know, you might have come across in your operating system, like independent processes and cooperating processes. So coming to independent processes, they are not affected or they doesn't depend upon any other processes for their execution. That type of processes are called as independent processes. Coming to cooperating processes, these processes execution depends upon the other processes. So they communicate with each other or they share some common resources. So it affects the execution of a process depends upon the other processes. So it is dependent on the other process, which is called as a cooperating processes. So especially to implement the synchronization between the cooperating processes, the communication here refers to exchange of information between the two different processes, and they require some synchronization to enforce the correct sequence of processes when they are sharing particular resources. Between, say, there are two processes that are sharing a resource, there should be some mechanism that has to be enforces ensures that only one process at a time can access a resource, right? So if no two processes can access a resource at the same point of time, so there should be some synchronization between the processes. So that is called as inter-process synchronization. So multi-processor systems usually includes various mechanisms in order to provide synchronization among the resources that are shared between multiple processes. So there are low-level primitives which are implemented directly by the hardware, and these primitives they enforce mutual exclusion to implement the complex mechanisms in terms of a software. And there are also a number of hardware mechanisms to implement a mutual exclusion. So if you consider a properly functioning multiprocessor system, it should always have a mechanism that should guarantee the orderly access to the shared resources and shared memory. So they should not at a time, if there are five processes which are sharing certain resources and the memory, all the five processes cannot access the shared memory at the same point of time, or all the five processes cannot access the shared resources at the same point of time. That results in conflicts. So in order to overcome this situation, there are certain mechanisms that can be implemented to implement the concept of synchronization among the resources. So one is the mutual exclusion. So this mutual exclusion is necessary in order to protect the data or the resources from being changed simultaneously by two or more processes. Two or more processes cannot change the particular data at the same point of time. That can be guaranteed by the concept of mutual exclusion. Next, coming to a critical section. What is a critical section? Critical section is nothing but there if you have a shared resource which is shared among multiple processes, that resource is present in the critical section. Whenever a process want to access a particular shared resource, it has to enter into the critical section, log the critical section, and then access the particular resource. And once its task is done, it will come out of the critical section, so that other process can enter and access the particular critical section whenever it needs. So here, in terms of a critical section, a binary variable called as a semaphore is used to indicate whether a processor is executing the critical section or not. And with the help of test and set, as we know, test and set instructions. So test and setting the semaphore itself is a critical operation which is performed. So here a semaphore variable is initialized by means of a test and set instruction in conjunction, in addition with your lock mechanism. So you can implement this test and set in two memory cycles. In the first memory cycle, you're going to access a particular semaphore variable which is present at a memory location, and in the second memory cycle, you're going to set the value of the semaphore variable. So using the concept of test and set, You can also implement the concept of synchronization among multiple resources that are shared between multiple processes in a multiprocessor system. So this is all about interprocess communication and synchronization. Thank you.